good morning, good evening, everyone. Um, so we were discussing about the basics of Python yesterday, right? And we also tried to have it installed, and we were trying a couple of initial programs. So maybe just as a quick check, did anyone face any issues yesterday or maybe later when you tried to set it up? Do you have a working Python installation in your computer? Anybody that doesn't have it still? Our team can help you, sort of like get it ready if required. Okay, all right. Yeah, looks like everybody has it then. Okay, so we were looking at yesterday, like the easiest way to sort of like get started with Python, if you have it locally installed, is to just open up the REPL. So you can type in Python or Python 3, press enter, and that will put you into this REPL. And the way you know that you are in the REPL is basically by these three greater than symbols, like that arrow symbol basically. The moment you see that anywhere in Python, you know it's the REPL that you're interacting with. And there you can straight away start writing code and it will run it very quickly. The usual option is where you open up a file, have the .py extension to it, save the file, write the code, whatever you want in it, save the file and run it with Python hello world.py. Both work the same way, but if you want to try something really quickly, especially maybe during the class, if you want to try something, the REPL, if you have it installed, is probably like the easier way, but both options would give you the exact same results. All right. And yeah, make sure you remember this one. Whenever you get into the REPL, to get out of it, that is to exit the REPL, you can press exit or Control Z and then enter. Okay, so that's how we sort of like get out of the REPL. I see this a lot of people like go into the REPL, but they don't know how to come out of it. So you just press an exit with brackets, enter, you're out of the REPL. All right. And then after that, yesterday we were looking at how we can take input from the user. So taking input is obviously very important, right? So you need some way to get some information from the user, because otherwise, how much can you do with the program if it doesn't have an input ability? So you can take input in Python using the input function. Okay. So anywhere in Python or even in other languages, you see something with these brackets next to it. That's the function, right? A function. So there is another thing called a method. I mean, I kind of interchange them here, but there is a difference between them. We'll come back to that. But for now, just think that functions and methods are the same thing. So whenever you see something followed by these brackets, it's a function. So our print that we saw last time, print hello, that print is also a function. Input is also a function. Okay. So you use the input function to get some input from the user. So we say input and whatever we want to prompt the user, right? Because if you just say input, it will just be the cursor waiting for the user to type something. So they may not know what you're asking them to type. So to give them some sort of a prompt saying, enter your name, enter your age, like what's your height, date of birth, whatever you want to take from the user, you give that prompt saying, like some sort of a text, and then you ask them to enter it. So whatever you give, that would be the prompt that is displayed to them, and then the cursor would be waiting to take some input from them. So if I run this once again here, so you see enter your name gets displayed, then I get this box. So here in this Jupyter notebook that I'm using, it shows as a box. When you try it out on a terminal, it would just be the cursor blinking, waiting for your input. But either way, you would see the prompt and then some sort of an input place where you can take something. So I can just type in whatever, and that gets taken back as the input, right? So that's the text I've given, and that goes into the program. So now the program can use that for something. Okay. And whatever the input is that you type in, right? So again, like in Python, we call everything as an expression, right? So when we say something is an expression, it gets returned. That is, it gets given back to your program. So the way you can capture that is by putting it into something we call as a variable. That is, it has some value. You put it into a box. A variable is kind of like a box. You put that in, and you put a label on that box, which is what we call as the name of the variable. in this case, I'm just calling it name, right? So whatever is the name of the user, we are storing it in a variable called name. And then I'm just printing it. So we say enter name, you get that, and we print it. So whatever you typed it in now can be referenced back again with a variable name. So the difference between this and the previous one is that in the previous one, you typed it in, it showed it here, but then it's lost, right? Because you're not storing it anywhere. But now when we store it into a variable, you're saving it somewhere. Now you could use that any number of times you want, right? So maybe in the future you want to say what was the name of the user again, you can just refer to the name variable that you have. All right. So you always want to save or store information that you want inside a variable so that you can reuse it multiple times. Otherwise, you get it, you look at it, and it's lost, right? It's like a phone number that you heard from someone randomly. Unless you maybe save it or make a contact of it, you probably will forget it. It's the same idea here. You want to save it somewhere in a variable so it gets the name and some dedicated storage. Okay. And whenever you type something in, so in Python to check the type of something, we use the type function, like fairly obvious, right? So you use type to get the type of something. So it says type is str. So str stands for string. So string is nothing but text. So it's a string of characters. That's why we call it a string. So whenever you type something, it automatically becomes text format or a string format in Python. But the catch there is, even if you enter a number, right? So here it's asking for an age, and age is obviously a number. So I press in some number, it still takes the class as str, right? So it's not a number, it's not an integer, or what we would expect, but the class type is a string, meaning even though you're giving a number, Python automatically treats anything you type in through the input prompt as a string or as text. Obviously, we don't want that, right? Because the moment something is text, you lose out on things that you want to do. I mean, for example, if you have a number, you can add one to it, right? Like if it's one, you can do one plus one. But if it is text, you cannot do anything. Like, text, there are very limited operations that you can do. So you want something, if you want something to be a number, you have to convert it into a number. Because this is a number, so you have to tell Python, like, you're wrong. It's not, I know you assume everything is text, but what I entered is actually a number. So make sure you convert that into a number. And the way you convert that is by saying int. So we say int, and then in brackets, the variable that you want to convert, so which is age, right? So age has the number 1000, which is a string. So I do int of age. Now we get 500, which is a number. So int stands for integer here. So integer is one of numbers, right? So int of that age gives us 500, which makes it a number. Okay. So this is how we convert. So if you want something as a number, you have to convert it. But if you're okay with it being text, then you can just leave it as it is, because by default, it is text or string. So you could do this in one go. That is, previously we did input and then we did int of it, but you could do all of it together. So you can say input and then put the whole input inside int, like the way we are doing here. So int and then input will automatically read something from the user, whatever they type in, will convert that into a number and then put that into the age that we have here. So here, I've previously run it. You can see I've entered age as 50. It would be 50, but text 50, but it automatically got converted into an integer, so it became a number, and that's why we see the class, the type of it is class integer, meaning it's a number now. So when something is a number, you can do whatever you want with that. All right, so this is how you do, and you can always do it in two steps if you'd like. So here I'm doing it in one step, right? So I'm doing int and input in both one, but we can also split it into two. So I can maybe just take input first. Here it would be a string, but then in the next time I'm converting that into int and putting it back into age. So now it would be an integer, right? So depending on how you would like to do it, you can do both. So let's say if I say 20, I get age 20, and age is now an integer. Okay, so this is how we sort of take input from the user. Depending on the type, we can keep it as text or convert into an integer. Okay, so we have one quick exercise here. Try it out. See if you're able to get it working. So the ask here is write a program where you have to ask two inputs. Like one input is basically their username, another input is age, but make sure age is converted into an integer. Okay, so name you can leave it as a string, but age convert that into an integer. All right, let's try it out. If you have any questions, let me know. We can talk about that. All right. Did everyone get it working? Any questions from anyone? Oh, are there any problems getting it running? No. Okay. Thank you. Yeah, I mean, for others, just in case you haven't seen, you can use the Q&A. There's a Q&A option there, right? You can use that to answer or ask questions as well. Okay. All right. So looks like everyone has it working. So we have a couple of exercises that you can try. Again, like similar kind of exercises, but with maybe slightly different results. But yeah, try it out. So this, I mean, like you can take a look at them now, but should be very straightforward based on what we will cover today and what we have covered so far. Okay. So these are some things that you can take and try it out. Should be fairly simple to get you going. All right. Okay, so that's how we take input from a user. So let's now switch gears and get into something we call as keywords. Okay, so keywords are really important in any programming language because these are words that the language internally knows about. That means each of them has some very special meaning to the language, so you cannot use them yourself, right? So like for example, you take false. So false means something to Python. So if you are like for example in the previous one, we were naming the variable as age, right? So we're storing age into age. So you should never name a variable as false. Okay. So these names are reserved internally for Python, and we shouldn't try to use those keywords with anything else. Now you don't necessarily have to remember them. It will automatically, it will become pretty much straightforward. You know, when you like start using them, most of these you would know pretty much by default. But just for now, these are all the keywords that exist in Python. And again, each of them means something very specific to the language. All right. So out of this, something to know is if you see most of these are all lowercase letters, right? Except for these three, which are what I've listed in the first, which is false, none, and true. So except for these three, rest of them are all lowercase, right? And there is a reason for it. We call them. It's because they are objects. Again, we'll come back to what objects are. So just remember that only these three are capitalized, and that to only the first letter. Rest of all the keywords, anything that we use in Python, they're all small, lowercase or small letters. Okay, so that's something. So let's start with the first uh, three that we have. So we'll start with true and false. Okay, so let's try to understand what these are, why Python needs them, and how we can use them ourselves. So true and false are what we call as Boolean values, right? So Boolean values are things that are outputs of logical operations. So logical operations are things where you ask conditions, right? That is this greater than 10, right? Is this less than 1,000? Is this equal to this other thing? So whenever you are doing that sort of a comparison, the output of that is what we call as a Boolean value. All right. So the output is like whenever I say is 5 greater than 10, the, the answer you can give is either yes or no, or in Python terms, we call it true or false. Right? Is 5 greater than 10? It's false. Is 10 greater than 5? It's true. Right? So true and false, or yes or no in English, we call it as Boolean values, meaning they are outputs of logical operations. So in Python, first thing to remember is basically we say everything is an object. Again, we'll come back to that if you're not sure what that is. But compared to other some other languages, so for example, we say Java is an object-oriented language. Python is also object-oriented. In fact, Python is even more object-oriented than Java. Why? We'll talk about that in a few classes. Okay. And whenever we say something is an object, we need to know which class they're objects of. So true and false are objects of the class bool. So bool stands for Boolean, right? And the way you know what type it is, which is basically what class it is by using the type that we have already seen. So whenever you do type and you pass in some number, depending on what you are giving in, you get different types, right? So we saw when you ask for type of a number, we get integer. But similarly, whenever you have a type for a decimal number, so 5.7 is a decimal number, the type is called a float. So a float is short for floating point number. So in computers, we don't call them decimal, we call them floating point numbers, but it's the same idea. So if you don't have any decimal point, if it's just 10, it's an integer. If it is 10.345, then it's a floating point number, okay, which is a decimal number. So float and int, both are types of numbers we have in Python. And then another type, which is what we're talking about here for true and false, they are bool. So bool stands for Boolean, right? So type true and type false, they're both Boolean values, okay? And obviously we saw type hello whenever that's something you're typing, anything with these quotes around them, single or double quotes, is a string, right? It's a character, like an array of characters, basically. All right, so basically both true and false are objects or types of Boolean. They're both Boolean types. Okay. Now, whenever something is a Boolean type, they are returned, like we said, as outputs of logical operations. Okay. So whenever I'm checking or comparing something, then the output would be either a true or a false. Right? So here, for example, yeah, we'll come back to this comparison in just a bit, but I'll say one equal to two. Okay. Uh, we know one is not same as two, so you get a false. Okay. Is five greater than or equal to three? Okay. Obviously we know that is, so it's a true. So whenever you run this in Python, you get a true as a result back. Okay. So these are how we would use true and false. So it's very rare that you directly use true and false yourself, but rather they come out as part of the conditions and checks that you do. Okay. So in programming, you verify things all the time, right? Is the time 10 p.m. now, right? So that you can do something, or is the user, this person, so that I can do something. So you always have a lot of checks that you want to compare. Based on that, you do something. So knowing when to do something is what we call as a conditional. That is, based on some condition, you do something, right? On Facebook, for example, whether don't know if you have it. Let's say YouTube, for example, right? YouTube has this YouTube Premium, right? So if you have YouTube Premium subscription, so that's a condition, then don't show ads. If you don't, then show like 1,000 ads every video, right? So you have those conditions that every program internally executes, and those conditions are nothing but Boolean operations. So it's a true or a false always at the end of it. Now, yeah, there's a question. Okay, yeah, someone's asking difference between type hello and hello. Yeah, so this is what the question. This is from Narendra Kumar. So you could have something like this, for example, right? So he's asking what's the difference between these two. I can say type hello. I'm saying type hello without quotes or with quotes. What's the difference between them? So with quotes, when you do, we saw it's a string, right? But when you do without quotes, if I run this, you'll see, yeah, you'll get an error saying hello is not defined, right? So what it's trying to do is basically, so anything in Python, right? If it's not surrounded by a quote, it thinks it's a variable or a keyword. So first thing it checks is hello a keyword that it should already know. So if we go back in the Python keywords, right, we don't see hello anywhere. So hello is not a keyword that Python knows about. So next thing it thinks is, okay, it's not a keyword, so maybe it's a variable that you have defined somewhere. So it tries to look, in the previous code that you have run, do we have hello as a variable? And variable is something that you define like this, right? So we say age equals something, so that becomes a variable. So age is a variable, but we don't have hello equals something anywhere, right? So because you don't have hello as a keyword, and because you don't have hello as a variable also, then it immediately thinks it's an error, right? That's why it says it's not defined. So it has to be defined either as a keyword or in some variable that you define. Because hello is not either of them, you get an error. So when you just put quotes around it, it doesn't do anything because it knows it's just a text. So it just gives you the type of that. But if hello was some variable that you have previously defined, so for example, if I say uh, hello equals 1, now hello has a value called 1. So now when you do type of hello, it checks for the type of 1, which is an integer. Okay. So yeah, the difference is basically when you put quotes around it, it just takes it as a string. But when you don't put quotes around it, it tries to see if there is a variable with it. If it is, it uses that. If it's not, it gives you an error. All right. Is that clear? Yep. All right. Yep. Okay. I think, yeah, if that's good, then let's move on to the others. Okay. Any other questions from anyone? No? All right. Yeah. So let's do a couple of things, right? So you may have seen this and tried sort of like try to wonder what this difference is. So there is in Python and in most programming languages, there is single equals and there is double equals, right? So single equals and double equals. Uh, in regular English or like in mathematics as well, if you remember from back in the day, to check if something is equal to something, you just say is x equal 4, and then you just sort of like go on and do something, right? So there is no special symbol in mathematics to differentiate assignment and checking. That is, how do you differentiate between x equals 4, where I'm saying I'm putting 4 into x, versus checking is x equals 4, right? So in regular mathematics, there is no difference between how you display that, right? But in programming, everything has to mean exactly the same thing because there should be no chance for ambiguity in programming. So what programming languages have evolved to do is they introduced a new equality operator, which we call as double equals, right? So instead of saying is x equals 4, we just say x double equals 4. which is exactly same as is x equals 4. Okay. And then this is nothing but x has value 4, right? So that's how both of these differ. So when you see single equals, we call that assignment, meaning whatever is the value on the right side is being assigned to the value on the left side. So x now has a value of 4 when you do this. But when you're doing this, you're not assigning or storing any value, you're comparing. You're comparing the existing value of x and checking if it is same as 4, right? Maybe I'll, to make it easy, let's say 10 for now. So is x equals 10? So x, we have put the value of x as 4. So now x is a box with a value 4 inside. The next thing I'm doing is comparing it with 10. X double equals 10 is asking the question, is x equal to 10? So we look at the box, x has a value 4, which is not 10. So we say that's a false. Okay. So the return value or the output of this comparison is false. That is, x is not equal to 10, right? So this is basically asking that question, is x equal to 10? If it is yes, you get a true. If it is not, you get a false. Okay. So that's how these two operators differ. So that's why we had to introduce a separate operator specifically in programming, because you don't want ambiguity, right? You want something to always mean the same thing in program, because computers, like at least by default, are not really smart. You tell them to do one thing and they can only do that one thing, right? So they need very specific instructions. That's why to make it easy for computers, we have introduced two different symbols, one for equality, one for checking if something is equal. So they are two separate operations. And that's why when you do x equals 4, there is nothing returned. So that's it. But when you do x double equals 10, you are doing a comparison. And whenever you do a comparison, it's a Boolean operation. So you get a Boolean value, a true or a false, as a return entity. Okay. So that's the difference between uh, single equals and double equals, right? So you have this everywhere in programming languages. So there are some languages, JavaScript, if anyone's familiar, where there is a triple equals as well. We will not get to that. So Python doesn't have it. So Python has single and double equals that we will work with. Okay. All right. So single equals again is just assignment. Double equals always would give you a true or a false as a return value, depending on what's the output of that operation. Okay. And any comparison we do, so greater than, less than, equals, all of these give you a true or a false as a return type. Okay. So these should be fairly straightforward. So 5 greater than or equals 3. So 5 is greater than 3. So it's true. Negative 10, is it equal to 5? It's not. So you get a false. Okay. So this is how true or false get used in Python. Again, you very rarely use false by itself. You always use comparisons, which give you a true or a false as a return value. Okay. One thing to remember is in Python, although you have this word called true and you have this word called false, they're internally, they have a value of 1 and 0. Okay. So 1, again, it's a separate thing. It's 1 is a number, true is a Boolean value, but true's internal value is 1. So that's why whenever you check if true is the same as 1, right, we get it true, meaning that true, all the true and 1 are two separate things, but the internal value is the same. That's why we get the value true, meaning true actually has the value of 1 internally, which means in some cases, you could interchange true and 1. Okay. Again, not always, because true is indeed separate from 1, but is does true internally equal to 1. So it's kind of like, I mean, it's maybe a contrived example, but you can think of it this way. Um, 4 minus 4 is 0, and we know 100 minus 100 is also 0. But technically, 4 minus 4 and 100 minus 100 are different, right? Because they are a different set of symbols, different set of characters in there. So technically, 4 minus 4 and 100 minus 100 are different, which is like the way true and one are different when you look at it, but their internal value, which is nothing but zero, or in the case of true, it's one, that is same. Okay, so maybe that's how you can think of how they're different but still same. Okay, so the internal value of true is 1 and the internal value of false is 0. So that's why whenever we do true double equals 1, we're asking is true equal to 1? You get true. Is false equal to 0? That's also true, right? So false has a value of true. And because of this, you get some weird operations. Again, something you never want to do, but because they have the value of 1 and 0 internally, it's possible to do. That is, you can add false and true together, which means nothing in English, right? What, like, 1 and 2 put together, but what is yes and no put together, right? Or what is false and true put together? It doesn't really have a logical meaning, but because they have a value of 1 and 0, you could do that technically. So 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1. Oops. Okay, I think I disabled something. All right, that's fine. So 1 plus 1 is 2, right? So that's a bit, again, never use them in code, but I'm just showing you that it is possible because of the values that they have internally. Okay. And we saw type of false is a boolean, right? But because false true have internally numbers like 1 and 0, we can actually convert them into those numbers directly by doing an integer. So you can say int of false, and that gives you 0. So you're asking false to be converted to a number, which is its internal value, which is 0. And then int of true, you're asking the true to be converted into some integer, and the only thing it can be converted to is 1. Okay, so this is how we work with true and false. So in summary, true, false, both are Boolean operators, Boolean values, and you get them whenever you do some sort of a comparison, whether it's equal to check or greater than check or less than check. Whenever you do some sort of a comparison or checking, you get true or false as an output. Okay, although not something you would need to use a lot, but internally true has a value of 1, false has a value of 0. Okay, so that's about true and false. um, so again, we're going through the list of keywords that we saw, right? So the first three keywords were false, true, and none. So we talked about false and true. Now the third keyword in that list is none. Okay, so let's see what none means in Python and how we can use that. But again, before that, any questions on Booleans, true and false? Is that clear? Okay, all right. Looks like there are no more questions. All right, so let's proceed to the third keyword. Again, keywords are things that Python knows about and cares about, right? So the hello example that we were talking about, hello is not a keyword. So if you type in hello, it doesn't care, right? It just does something else. But when you type in none, it knows what none is, or you type true or false, it knows what it is. So it goes and looks for them specifically. So none is again another special thing, special keyword in Python. And the reason we use it is to represent an absence of a value. Okay. So far we saw how to show something has some value, right? X equals 3, meaning X has something inside it, the value is 3. But there are cases where you want to say there is nothing here, right? That is, there is an absence of something. That's where Python uses none. Okay. And again, remember, none is capitalized N. So N is capitalized in these. So same with true and false. True, false, and none, in all three of them, the first letter is capitalized. Okay, so that's something to remember. For those familiar with C, C++, Java, you may have heard of this keyword called null, which is in those languages. So it's kind of like that. Okay, so it represents the absence of something. Uh, and again, anytime you see something is capitalized in Python, right? Know that it's an object, and whenever something is an object, it has a class. Again, we'll come back to what these are, but just so familiar with the terms class and object, I'm introducing them over here. So none is an object, and none type is the class for that object. Okay. So, and again, anything you have in Python, you could always do a type, right? So you can do type of none, and it gives you what type it is. So none has its own type in Python called none type, right? So it's as simple as that. One is an integer. Hello with quotes is a string. True and false are bool, but none is none type. Okay, so that's how Python defined it internally. Okay. Now, the way you use none is basically you just assign it to things, right? So you put x equals none, and that's it, meaning x has nothing inside it. All right, and if you print that, you get none. Now, this may seem a little counterintuitive, right? I mean, it makes sense that, if you want to put something specific, then you would use that, like, x equals 5 makes sense because you are putting 5 into x. But what reason is there to put nothing into something, right? I mean, it's like having an empty box, but not using it for anything. We'll sort of look at a couple of examples and see if that makes it a little easier. But yeah, I mean, that's what this is literally for, right? So it represents the absence of something. It basically represents nothingness. So you can put that nothingness into something. Okay. Again, it may be slightly confusing, but let's see a couple of examples of that. So first thing is, one of the reasons in which you could use x is use none is basically like this. Just to say it has nothing in it. So that is one way. Or another way is maybe you had something to begin with originally, so x equals 5, but now you want to explicitly say that remove that and make it empty, right? So that could be another way in which you could use this. So when I say x equals none, you are essentially taking off whatever was there. So again, you have this box, there was 5 before, but now you're saying none, so you just remove 5 entirely, so you have an empty box. Okay, and that's why we say when we print x, you get none. Okay, so that could be one way in which you could use none. That is, you can use that to replace existing values, right? So there was something in it, you don't want it anymore, you replace that and you put none inside that. Okay, so that could be a way in which you could use it. And none, something to remember, again, this is slightly different from other languages. We saw that true and false have values of 1 and 0 respectively, but none does not have an internal value, or it's not same as what we would expect. So none is not 0, none is not false, which you may expect because they're all the negative equivalents, right? 0 means absence of something. False also is like absence or like not of something. So you may think that maybe none is related to them in some way, but at least in Python, they're not. So none, 0, and false, they're all completely different in Python. So that's why none double equals 0. I'm asking, is none equal to 0? You get a false, meaning none is not 0. I'm asking, is none equal to false? Which again is false, meaning none is not false. Okay. So this is how, again, like the comparisons with null, with none. And final thing is, whenever you have two nones, like you have x is none, y is none. If you compare them, you would get true, which makes sense because none is equal to none. So the only thing none can be equal to is another none, but nothing else. So it's not equal to 0, it's not equal to false, and nothing else. Okay. So none is equal to none. That's it. Okay. And although examples that I'm giving are maybe slightly, again, sort of artificial and manufactured, because you wouldn't use none like this in practice. It in fact, like, it's very rare that you'd actually type in the words none into a program. Like true and false, they're always returned. Okay, so true or false are returned whenever you do some sort of a comparison, right? Is 3 greater than 10? You get false. Is 1,000 like greater than 10, like you get true. So depending on the operation, you get true or false, but it's very rare for you to actually use true or false. So none is kind of like that. Although I'm showing you, you could use it if you'd like, in this fashion. Lot of times what happens is none is returned from some other operations to mean something. Like, if maybe the success condition of that operation is that it will give you something, but if it gave you none, means it failed, right? So it could be something like that. So know that none exists. We'll see examples of how it actually comes into practice. But if you want to use none in a variable, you could do that, something like this. All right. So you can actually store none into a variable. You could replace existing things with none and so on. So all of these are something you could do, but usually not something that are common, right? Because what purpose is there of saving X as none, right? I mean, don't even do that, right? Like if you don't put it, it means like there is nothing anyway. So like it may not make a lot of sense, but this is just to show that it's possible, not that you should do it. Okay. So how none gets used is something when we come to functions, we'll sort of see how we could use that a little more. But at least for now, know that none is a keyword that is used in Python. Okay. So we looked at three keywords so far: true, false, and none. Okay. Now let's look at some logical operations so we could actually start writing a little more complex programs than what we have done so far. Okay. So we saw greater than, less than, equal to, right? So those are your typical logical operations. Apart from that, we also have these three logical operators in Python. And again, these are common in all languages. So we have and, we have or, and we have not. Okay. So let's see how we could use them. And again, these should be very straightforward, again, from the way we use it in our languages as well, right? Whenever we say and, it means this and that. I mean, like I'm already saying and to explain that, right? So whenever we say somebody is, I don't know, like he's smart, he's rich, right? So you say he's smart and rich. So meaning both are true, right? So that's exactly how we use them in the languages as well. Same with or, either this or that. Only one of them is true, or maybe both of them can be true as well, but at least one of them has to be true. And not, again, as you can guess, it's not good, right? So it's the opposite of good. So it's exactly the same usage here in Python as well. So let's see some examples. So I'm saying age equals 20. Okay. And maybe let's say I want to check whether the person with this age is a teenager or not. So I know teenager is somebody who is from 13 all the way to 19, right? Maybe I think I should maybe take the equal to off here. Yeah. So let's say I want to anyone from 13 all the way to 19, right? That's my teenage years. So I could do like to check if that is the case. I want to do two comparisons, right? It has to be greater than 12, right? That is, or maybe I could even say greater than or equal to 13. Both are possible. And it has to be less than 20 or less than or equal to 19, right? So that's how we define teenagers. So it's basically 13 to 19. So let's actually make it easier that way. Less than or equal to 90, right? So only when both of these conditions are successful, we say somebody is a teenager, right? Because just saying age greater than 13 is not enough, because they could be 40, they could be 100 years old. They are not teenagers anymore. Maybe they're teenagers at heart, but at least in reality, we wouldn't call them teenagers. And similarly, age, if you just have age less than 19, even like a 3-year-old would be a teenager, right? Which again is not what you want. So you want this range to be true. You want both of them to be correct. So for that to happen, you need to do an and, meaning this should be true. They have to be greater than 13 and they have to be less than 19, less than or equal to 19. Okay. Only when both of them succeed, you say the final thing succeeds. So you get it true. Okay. So this is how we use an and operator. So and operator is used whenever you want to join multiple conditions, right? So obviously this is a condition of its own. So you are checking age greater than or 13 or not, and again you're checking age less than or less than 19 or less than or equal to 19 or not. But you want to combine both of these conditions you put an and between them. Okay, so that's how we use. So similarly, we use or as well, but for different reasons. Okay, and I hope most of this should be straightforward for everyone. Like you may have studied math, Boolean operations at some point, hopefully, but this is what we call as the truth table, right? So true and true is true, true and false is false, false and true is false, false and false is false. Meaning, whenever you are doing and operations, because and always joins two things, right? So like you have condition one and condition two. So you have two conditions to check for in any given point of time. So the final result of and would be a true or a false. So it's true only when both the conditions are true. That is, this is true and this is true. Only then the final result is true, like the way we have here. But if either of them is false, right, then the output itself is going to be false. Right? So that's why you see there is one false, or if both of them are false, that's also false. Okay. So this is the and truth table. That is when you get a true out of it, when you get a false out of it, when you use and. Okay. So I hope this is straightforward, right? Like, do we need any additional explanation for this? Uh, so again, it's kind of simple in the way you would normally think in terms of language as well. So, like this and that is something we always use, right? So only when both are correct, you would do something. If not, then you don't do it. Okay. So maybe like let's say, a common thing we have going on in India, right? We have a lot of vegetarians in India, and you also want to make sure. Let's say you're looking at a food label that you are trying to purchase. It shouldn't expire, obviously, because if it expires, it doesn't matter if it's vegetarian or not. You wouldn't purchase it. But if it doesn't expire, then you want to check if it has that green symbol or not, right? Whether it's vegetarian or not. So you want to make sure anything you purchase follows both of those conditions. So that's a perfect scenario for and, right? So it should not have expired. So and you have to make sure it is vegetarian as well. So now if it expired, which means the first condition is false, then it doesn't matter whether it's vegetarian or not, you are not going to buy it. Right? That is a false. So if it hasn't expired, but if it's not vegetarian, right? So again, one of it is false, so you would skip it. You wouldn't buy it. But if both are true, it hasn't expired and it has that little green dot over there. No, it's vegetarian. Now you go and purchase it. Okay. So that's how you can sort of think about it. If any of those are false, the output is false, meaning in this example, you wouldn't purchase it. But if both are true, you would purchase it. So it's true. Okay. So this is what this is showing over here. So true and true, true and false, false and false, you get these values. Okay. All right. So next, let's talk about or. So and or, again, very common in the language, right? So and is where both conditions have to be true to work, or either of them can be true, right? As long as one of them is good for you, you can go ahead and start using it, right? So again, maybe an example is uh, you want to go out, maybe you have a bike at home and you have a car at home. So as long as, and maybe let's say you have, your parents or your brother, sisters, whatever, who also maybe, are using those vehicles. You want to go out, but, like you can go out as long as one of those is available, right? You have your bike license, you have your car license. So as long as one of those is available, you can go to your destination. So that's kind of like an or operation, right? So bike exists, you're good. Take the bike, go away. It doesn't matter if car is also there or not, right? So there's only car, you're still good, right? You take the car and go away. If both are there, then also good. You can pick whichever one you want. If both are not there, then you are stuck. You cannot go anywhere, right? So that is the or scenario where either of them is available. Your your operation that you want to do is success. But if both are false, right? So like in the case where bike isn't there and the car isn't there, then it's false, and like false or false, then the output is false. Okay. So these are your other logical operators. So true, false, sorry, greater than, less than, equal to are the other operations that we saw, and or are also your other logical operations. Okay. Now finally let's come to not. Okay. So when we say age equals 30, we said we're assigning it, we're not checking anything. But when we do age double equals 30, that's when we are checking it. Is age equal to 30? And it is, because I've just put 30 inside it. Obviously, 30 has to be equal to 30. So you get it true. But along with that, in Python, we have this other symbol called not equals, right? So again, in mathematics, if you remember, we used to do equal to with like a strike through on it, right? So that's the not equal to symbol. It's the same thing here, but like in Python and other languages, we represent with an exclamation equal to, which means not equal. So the way you read that is age not equal to 30? Okay. So double equals would make it is age equal to 30? Here we're asking is age not equal to 30? Uh, which obviously is not true because we have false, right? So age is equal to 30, so you get false. So the other way of getting that is by using the third keyword that we were talking about, which is not. Okay. So you could put a not in front of something and that flips it, right? So when you have something is good, you put not in front of it, it becomes bad, right? So it's the same idea here. Age equals 30, we said is true, but when you put not in front of it, it becomes not true, which is false, right? So you get false. And similarly, basically, you can put not in front of anything that is giving a true or a false already. So age not equal to 30 is giving us a false. So you put a not in front of it, you get a true, right? So not false is true, not true is false. Now, although I wouldn't recommend it, you can certainly do something like this where you can put multiple nots together. Again, never ideal, it looks really bad, but if you want to, you can certainly do that. You are essentially, it's kind of like an on off switch, right? So you're like switching on and off like 1,000 times for no reason. But yeah, like this is false. You put a not in front of it, it's true. Then you put a not again, it's false. Then you put a not again, it's true. Right? So that's how you sort of look at it. So it flips it every time. So not true is false. Then again, not false is true, and so on. So you kind of keep flipping it back as many nots that you have. And similarly, as we saw, not true is false, and not false is true. Okay. So this is how we compare with these operations and or not. Okay, let's take a quick pause. We talked about a few more operators here. Any questions so far? So we saw how we would use logical operators like true, false, and how we can combine them with or and not. All right, no questions. Okay, good. All right, and again, so the next keyword or next operator that we're going to talk about is is. Okay, and again, like if we look back, each of these are keywords in our list. So you see false, none, true. You can see and, you can see or, you can see not. So each of these means something to Python. So that's why we're straight away using them without having to do anything. And the next keyword we're talking about is is. Okay, so that's what we look at. So is another keyword you have in Python, which is also used for comparison, but it's used explicitly for identity. That is, you whenever you do is, what you're checking for is, are they exactly same? Okay, it's kind of like double equals operator, but they're not the same thing. We'll see how they are different in just a bit. So in Python, we have something called as lists. We'll talk about that a little bit before, but take a look at this just to sort of see how we look at it, right? You have A, I'm calling it one. So it's a list of 1, 2, 3, meaning it's a collection and there are 3 elements inside it, 1, 2, 3. And then I have B, which is also 1, 2, 3. and then I have C, which I'm saying is nothing but A. So C is equal to A. Okay. So now let's see the difference between double equals and is. So both double equals and is are used for comparing it. Check if something is equal, but what they consider equal are slightly different. Okay. So when you do A double equals B, what you're checking is if A and B are same, which looks like it because they have the exact same thing on the right side. So you get a true for the first one. So this is true. But when you do A is B, you get a false. Okay. Again, like take a look at it. We'll see why that is in just a bit. And then look at the next thing. So we say print A double equals C. That is A equal to C? We get true. And then I do A is C. I get true over there as well. So out of this, A double equals B, A double equals C is always true in both of the cases. But A is B is false, while A is C is true. Can anyone care to take a guess on why that could be happening? Uh, because they're all equal here, right? So we're saying A, B, and C, they're all the same thing. But why is that they're behaving differently between double equals and is? Anyone care to take a guess? Storage. Okay. Yes. Do you want to expand a little more on that? Yeah. Yeah. It's related to storage. Perfect. So how is storage affecting is versus equal to?
Yeah, Narendra, you can unmute and you can talk actually. You can explain.
Yep. Go ahead.
Yeah, the location where A and B stores are the different locations. So
Mhm. Yeah. Perfect. Yeah. So again, like memory management will come back to, but that's exactly the reason. So for now, the way you can think of it is right. Uh, I don't know how many of you used to do this as a kid, but I learned math at home using coins, right? So, like, my dad, my mom used to like give me, like 5 rupee, 10 rupee coins, like 1 5 rupee coin, you have 5 rupees. Put one more 5 rupees, how many do you have? So that's how I learned 5 plus 5, like a lot of times using money rather than actual numbers. So let's say we're talking about such a scenario where you have coins in front of you. So you have one 5 rupee coin and another 5 rupee coin, right? So obviously both of them are 5 rupees. So they have the same value, right? So whenever they have the same value, you whenever you do double equals, you get it true. But what is trying to guess is it's not about the value, but is it the exact same coin, right? You are looking at the coin you have in your right hand, and maybe somebody takes it away, and you are checking if is it the exact same coin, not another 5 rupee coin, but is it the exact same thing? Maybe it has like the dent on the right side, the same manufacturing year, whatever markers you have, but is it the exact same coin? If it is the exact same coin, then is would give you true. But if it is not the same coin, but the same value, right? So it's a different 5 rupee coin, but still 5 rupees. So the value is same. Then double equals becomes true. That's why we see in both the cases it's true because the value is the same. But when you do C equals A, right? What you're saying is you are not talking about another 5 rupee coin. You're saying C is also the exact same 5 rupee coin, or in this case, exact same list. Okay. So because it's the exact same thing, then is becomes true. But if they're two separate things, because they are separate, they're not the same thing, is would give you false. But since the value is same, the double equals would be true. Okay. So we'll come back to memory management and how the actual allocation happens in some time. But hopefully that gave you maybe a little bit of a sneak peek of what to come. So is and double equals, what they're doing is both comparing equality, but what they think is equal is slightly different. Double equals think if it's equal if the value is the same. but is thinks it's equal if it's the exact same thing, right? So I mean, it would be like you give your maybe your friend your bike for a day, and you get back a different bike, and they say it's the same value, so why do you care, right? It wouldn't. That's not how it should work, right? So there are cases where you want to check if it's the exact same thing, and there are cases. I mean, maybe in another example, maybe you gave your friend maybe 10,000 rupees or like $100, whatever, and they gave you back. There you are not particular, are you giving me the exact same note I gave you, right? You are not particular about that. So in those cases, checking the value is enough. Okay. As long as the value you gave and the value you got is the same, you're good. But if you gave your bike or your car to somebody and you get a different car, then that's not good. So in there are cases where you want to check for the value. There are cases where you want to check for equality, as in is it exactly the same thing or not. That's what we call as object identity. Okay, so it has to be identical, not the same value item, but exactly the same thing. Okay, so that's the difference between double equals and is. All right. So with that, yeah, so these are some other keywords that we will talk about in a little while. So I'm just like making sure you're familiar with them a little bit. So break, continue, class, we talked about that a little bit. Def, if else, for, while, lambda, and return. Okay, so these are the words that are coming up. So stay tuned, I guess, for these. We'll talk about some like the next class or the class after that. All right. So with all of that, let's get to a little more detail so we can actually build a little more interesting programs. Okay. So let's talk about variables. I know we have created variables, we have used variables already, but let's do a little more deep dive on Python variables so we could start using them in our programs. So first thing about a variable. So what a variable, we talked about it. So variable is basically a place of storage, right? So it's like a box. You put something in it, you name the box something, that's a variable. You can put anything inside a variable. It could be a number, it could be a text, it could be a whole book, right? Whatever you want. And that's a variable. So basically a variable is a place of storage, right? I mean, in more technical terms, every computer has a memory, right? So a variable is basically some labeled memory, right? Your program just looks at your RAM, like says that that's the place I'm calling A. So that's what a variable is, basically some location in your memory, in your RAM. So again, maybe one thing, hopefully people are familiar, but in case not, in programming, although you have two types of memory, right? You have storage, your physical hard disk, and you have RAM, which is the temporary memory. In programs, unless specified, whenever we say memory, we're talking about the RAM, not the physical hard drive storage. So memory is always RAM, again, unless specified. You may also talk about the file system storage, but unless otherwise mentioned, we're talking about always about RAM. So whenever I say a variable is a place in the memory, I'm talking about in the RAM. Okay. So in the RAM, however many gigabytes you have, a small part of that has been labeled whenever you create a variable with that name. All right. Okay. Now, again, comparing Python with other languages, again, C, C++, Java, all of them. So they generally have two different steps. One is called creation, another is called assignment. Okay. In Python, there are no separate steps. It all happens together. Okay. So in Java or C, C++, you can do them like there are two separate actions there. But in Python, it's exactly the same. So what do we mean by that is, maybe I'll show something like this. Let's say, again, this is Java code for now. Let's say you are storing a number in Java. You would do something like this. Again, it's not Java syntax, but I'm just trying to simplify it. You would first say int x, meaning I have a variable called x. It's going to store integer. You have that. And then you go and put 4 inside it. Okay. So we call these two steps separate. I mean, you could do them together as well if you'd like the way you see over here. But generally, these are two separate steps. So one is called creation The other is called assignment, meaning here you created a variable called X. It has nothing in it yet, but you created it. So there is now a box with the name X on it. Now you're coming in and putting 4 inside it. So now the box has something. Okay. The same thing happens here, but it's still the two operations that happen together. Okay. So this is how it works in Java. But in Python, these are not separate steps. You straight away skip the first part. There is no int x step in Python. You straight away go x equals 4, or in this case, num equals 5, and that's it. Okay. So that's how we define variables in Python. So to start off, there's a difference compared to other languages. In Python, there is no variable creation. There is only assignment. The variable is automatically created when you assign something. Okay. So the moment you have something to store, a box gets created automatically for you. But in other languages, you have to create the box first and then put something in it. But in Python, you have something, box is already there for you. It's automatically created. So that's the difference between Python and some other languages. Yes, somebody has a question. Go ahead.
So we don't have any default values?
Not in Python. So unless, again, like the default value you could think of as none, meaning it has nothing, but other than that, nothing. So you straight away put something in it, and that becomes the default value. If you don't do, there is no value inside it. And yeah, that's why it's kind of different from your Java, C or C++. Right? When you put X, it has some default value, meaning it has the nothingness, but nothingness that is defined. But in Python, there is no such thing, because you directly do this. Until you do this, X isn't there, so there is no reason for it to have a default value, basically. So the creation happens straight away. So, or to put it another way, the default value comes into picture only when there is a gap between creation and assignment, right? So until you assign, it has to have something, because it cannot have nothing in any language. So you create it, but it hasn't been assigned yet. So now you put a default value. But in Python, you are not creating at all, right? You're straight away assigning. So there is no gap between creation and assignment. So that's why there is no default value as well. All right.
So just want to know, if I use int x and later at runtime, I want to assign some value, is that not possible?
Yeah. So one thing is there is no. So yeah, maybe let me make sure it's not confusing. So this is Java code, not Python. So in Python, there is no int x. You just say x. So this is what that looks like. So you say in Python, you say num equals 5 or name equals Python, right? So there is no creation step, or there is no defining step where you say num is my number, which has an integer, or name is my variable that has a string in it. So there is none of that creation or defining step. You straight away assign values directly. Did that answer the question?
Yes.
Yeah, so basically there is no default value. And again, the reason default value comes in is if there is a gap. If there are two separate operations, then obviously there's always a gap. So you have to have something default. But in Python, there is no default value. If you don't do this, right, num itself doesn't exist. So there is no need for a default value. So that's how you should see. And not just this, but Python is a dynamic language, right? So which means it doesn't care about the type at runtime. We were discussing it slightly yesterday as well. So as long as you know what type you're working with, Python is happy to do whatever you ask it to do. So which means I can start with a as a number, which is an integer here. And in the very next step, I can assign a string or a text to it. And in another step, I can go back and assign a decimal number, which is a float to it. So Python doesn't care about the types, right? So again, this is in contrast with some other languages where you have to strictly say, just here we have an example, right? You have to strictly say int x equals 4, meaning you're telling Java that x can only be an integer, which means you cannot assign anything else to it. It cannot be a string, it cannot be anything else. But in Python, it's all dynamic, meaning I mean, in short, it doesn't care about the current type you have it is set to. So you could give any values you want, and as long as the operation you are doing it works for that type at that given point, Python is completely happy. So it doesn't stop you from going from an integer to a string to a decimal and coming back to integer. You can keep changing it like 1,000 times in the program if you'd like. It's not a good practice because it can, I mean, how many times you will keep track of as well. So maybe you will make a mistake as well, but at least Python doesn't care, or Python doesn't enforce anything. Okay, so that's the difference to keep in mind. So Python, that's why we call it as a dynamic language. So types are dynamically decided. Whatever is the type currently, it uses that, but it doesn't care whether it was in the past a number, a string, or anything else. If it's a number now, that's all it cares. Okay. So that's how Python variables are, right? And in any
Sorry.
language, yeah, sorry.
Yeah, and continuation. So we don't have any global variable or local variable something.
Define an example. You do have global variables in Python, but I want to make sure you talk about, like, we're talking about the same thing in here. What would be an example that where you compare global, where you differentiate global and local?
Just like an example in Java, in class level, I define some variable, and in later part in our methods, I want to reuse it in a different methods.
Yeah, yeah, that exists here as well, and you can also change the scope. So, I mean, I don't know if others are familiar with this, but maybe just to answer your question, it's all defined by the scope. So if you have something, let's say we're talking about a single file, you have a equals 10 defined at the top of the file. Then if you haven't defined a again, everywhere in the code, it's always a equal to 10. But let's say within some function, you now defined a new a, meaning it has like 20 inside it. Then only for that function, a becomes 20, but for the rest of the file, it's still 10. So it's still scoped. So a becomes, the new a would be your local variable, but a that is outside its global variable. So based on the scope, whatever applies, that gets picked up. All right.
Okay. Yeah. So
Yeah. So
same
both
variable
exist
can be
basically.
used. Same variable can be used in a class level. A can be used, and the same method level, I can use the a again with the
Yeah,
different values.
you can. Yeah, with a different value. Yes. Okay, now I understand your question. So you're comparing with Java where you cannot override the type, right? Yeah, now I see the question. Yes, so in Python, that is perfectly possible. So again, like basically in Java, if you define something as an int a, then even if you overwrite it in the scope, it has to be of the same type, right? Otherwise, Java would throw an error. But yeah, in Python, it doesn't care, like, because an a can be like something else on the top, but as long as you define it in the scope a different value, you get a different one there. So yeah, like that, it's possible in Python, but not in Java.
Okay.
Yeah. All right. And the moment we say variables, right, you have to be careful what you name as variables. You cannot just call something, anything you choose to do it. So there are some conventions that we have to follow. So first thing which we defined is it cannot be an existing keyword, right? So any of the keywords that we saw in that list, you cannot. So for example, true is a keyword. So you cannot name a variable true. That's not going to work out. And you always must start a variable with a letter or an underscore, meaning you cannot have a variable that's starting with a number, right? So I can call my variable age, or I can call it underscore age if I want, but I cannot call it one age, right? So you cannot start with a number, right? So that's the other one. So it has to start with a letter or an underscore, but it cannot start with a number. And the variables can only contain your typical alphanumeric characters. So capital letters, small letters, numbers, or underscore. You cannot have dashes in the name. So for example, you can have your name, variable name as first underscore name, but you cannot have first dash name. Dash is not possible because the moment you have a dash, it gets treated as a subtraction, minus, and it has a different meaning. Right? So that's why, to keep it unambiguous, you can only use underscore, but you cannot use a dash. And similarly, you cannot use spaces as well. You cannot say first space name. right? That's not a variable. So it has to be together, and it has to be alphanumeric and an underscore. So only these are permitted in your variables. And variables are obviously case sensitive, as you could expect. That means X and capital X are different, and age and capital age are different. So they are two separate variables, and that's why you never want to confuse people by having the same variable with different cases. General convention is to always stick to lower cases for variables. You'd never really want to go with capital letters because that can add an additional layer of confusion. So you just want to always have lowercase letters, but if you ever choose to, they are case sensitive. So if you do age and capital H, they are treated as two separate variables. They're not the same thing. Okay. So these are some of the conventions, some of the things to keep in mind whenever you're creating or naming variables. All right. Printing, we saw examples of this already. So you have a variable, you print that variable with A, you get 3, right? Meaning that gets printed. If you have multiple variables, you can print them with the print function with a comma. So print A, B, C, and it automatically prints them. And one thing to note is it automatically adds spaces for you, which is nice because a lot of other languages don't do this. So in other languages, you get the output as 345, like 345 together without spaces. That may not be good sometimes. So Python, the moment you put a comma, A, B, it automatically prints them with a space in the middle. Okay. So you can also format the text that while you're printing it. So you could do something like this. So we can say your age is, and then I put a comma age. So because comma automatically adds the space for me, you can see your age is, and I get a space, and then I get 20. Or if I want space myself, but I'm not using a comma, I could add it myself, where I can say, so we can add two things with a plus. So we call it concatenation, right? So you can say your age is, and then you put a plus, and then you add the age, which is a number. So because it's a number, you have to do a string. So you have to, you can only add two strings. You cannot add a string and a number. So you have to convert age, which is a number, into a string. And now you can add both of them. And now you can get the same. So note that whenever I'm doing a plus or a concatenation myself, the space wouldn't get automatically added. So that's why I had to give a space myself over here. So if I remove that, you can see that space goes away. So if you put a comma and some variable, Python automatically adds the space for you when it displays it. But if you are adding it yourself, if you're constructing the whole string yourself, then obviously you have to add the space yourself. So I put a space, and then that gives me a space 20. Just a minute. Yeah. All right. So this automatically gets added if you have a comma. So a lot of times it makes it easy for you to just let Python add it. Otherwise you'd have to do all of this magic, yourself. So makes it easy when you let Python take care of it. So continuing with the same, I can add a few more things. So let's say I have a name variable called alpha, age variable called 20. I can print a whole string like this. Your name is alpha, your age is 20, just by using print. Okay. So your name is becomes my first part of the print. And then I put a comma and name. So that adds a space, right? So your name is alpha and your age is whatever, and that becomes a space. So everywhere a space, everywhere there's a comma and something after that, it automatically becomes a space. So this is a space like that, this is a space like that, and this is also a space like that. So Python automatically adds those spaces for you, so makes it easy when you're trying to print something. So we have another way of printing, which are called F strings. So we'll sort of come back to this a little later. But if you don't want to sort of do this, where you are sort of like doing a quote, comma all the time, you could do all of it in one place by using something called as an F string, where you put an F in front of the quote and you directly put the variable names inside. So that output is also exactly same. We'll talk about f strings again in a bit. So that's fine if you don't understand what they are, but just know that there are multiple ways in which you could print something, right? So if you want, you can just do it this way, where everything is like quote, comma, like you're sort of like adding things like that. Or if you want to put everything together without breaking into like one single string, then you could do that as well. So you can have everything together, which are called as f strings because you have an f in front of them. All right. And again, we haven't talked about lists just yet, but you can print anything like this. Like if you can put name and you can just put that over there. So it becomes your name is ABC and your age is 20. So all of those are possible with print. So print, you just give it anything you want, it can handle it, and it will print it out depending on like whether it's single quote stuff, whether it's quotes, commas, or like one formatted string that you're creating. So either way, whatever you ask it to print, print can print it. All right. So let's do maybe a couple of exercises. These should be very quick. So yeah, first thing, let's have variables created. So save your name inside a variable. So it would be something like this, and then print it with print. And then update that, basically adding another name, like a new name basically in the same variable, that is you're overriding it, and now print that new name instead. And finally, you take an input from the user. So instead of directly setting the value yourself, you take an input from the user, what is your name, what's your age, and then print a message like so. Your name is, or sorry, user's name is, and user's age is, right? So all based on what we have sort of studied so far. So try it out, make sure you're able to get it working. Yeah, and we're also like about to end on time. So like once we are good with this, we'll pause here for today and we can take any questions that are there.
So I'm comparing with Java again. So in Java,
Yeah,
we
sure.
have a like private, public, protect, some kind of things, right? Similarly,
Yeah.
do we have anything here?
No. I mean, I'll say no with an asterisk on top, but at least for now, no. And everything in Python is public. So Python doesn't have a concept of private at all. I mean, protected also doesn't exist. Everything is public in Python. So yeah, if you're coming from a language like that, where things are explicitly scoped, private, protected, etc., you have to slightly change the way you think about it. I mean, it's not too much because there you explicitly say private, here you don't say anything. But yeah, that's something to keep in mind. There you may think that by making private nobody can access it, right? So you're sort of like hiding things from a user, but in Python everything is public. So if you're putting your code out there, running it anywhere, everyone can see what's happening in the code, whether you want it or not. So yeah, in short, there is no private in Python.
Okay. And one more thing, like in Java, it is a Dart Java, and then we have to compile like Dart class, then only it is an
Mm-hmm.
executable, right? So is there in
Yep, yep.
something in Python?
Yeah, so we were discussing it yesterday. So
Yeah, I
Java
missed
is what we call as
yesterday's.
okay, I see. Yeah, so in Java we call it a compiled language, meaning you write your code, so your .java, then you compile it. That's where you get your class files, right? So rather object files as we call them, and then you run them, which is your execution step or your runtime. So you have three distinct stages. So you have your coding time, you have your compile time, and you have your runtime. But in Python, the compilation is taken out. So we call this as an interpreted language. So instead of compilation happening separately, you write code and you run it. So you skip the compilation altogether. So in Python, there are only two steps. So there is no compilation. There is no Java C hyphen space file name. That doesn't exist. You write code, you straight away run it. So that's why we call it as an interpreted language. So that doesn't mean compilation isn't not happening, because at, like, compilation is a process of converting code into machine understandable code, right? So that has to happen. It's just that in Python it happens at runtime instead of at compile time. So in Java, you first compile it and then you run the compiled class. But in Python, we call that process interpretation, but it's actually compilation and runtime together. So it's just that we are postponing that to runtime. So it exists, but not something you have to do. Python takes care of it.
Okay.
Yeah, we call it an interpreted language. That's right. So interpretation essentially means doing compilation and execution at runtime.
And I was running these programs in command prompt. It's not allowing me to have a multiple lines. Can you show me how to run multiple lines of code in command prompt?
Multiple lines. Let me switch to that. See what you mean.
Means like, okay, you want to execute, okay, a couple of lines in what at same time, like, okay, how you are executing from the file, right?
Like, let's say, what would be a multiple line? Like if I say here, I can do print age, something like this. So I'm able to do this, but what do you mean by multiple lines there?
Yeah, same thing. If I enter, it's not working for me. Okay.
Oh, okay. Yeah, like if you are in the REPL, so again, like you should have these three arrows here. The moment you are there, it should, anything you type in will automatically get run by Python.
Okay, actually I was using semicolon, so.
Okay. No, that should also work, because like semicolons are not important in Python, but
Can
it
you
still
try with
accepts
multiple
them.
lines? A semicolon and then print.
Oh, like this?
Yes. No,
Oh, that should
just
also.
enter. After semicolon, I'm trying to enter.
Oh, okay. Yeah,
It's
like that.
working. Yeah.
Yeah, it's working. Yeah, so like semicolons work in Python fine. We prefer not to use them, but this should be fine. Shouldn't be a problem. When you could even like put things together if you'd like something like this. So that would work as well. So is it giving an error or something?
Yeah, I got it now. Yeah.
So you are on the REPL, right? You're trying this on the REPL, correct?
Yes.
Yep. Yeah. So yeah, it should be straightforward. Like anything you do here would work exactly the same. If there is any specific error, we can look at it, but otherwise, maybe just restart once, like close the REPL once again and try. It should work. All right. Okay.
Example,
So yeah,
it's taking an input, right? That case I got this issue. Normal, if you give A is 20, then it is working fine. But when we ask an
okay.
input, right, it is breaking there.
Oh, okay. Let's try that. Should also be fine. So yeah, it
So
waits
after this,
basically for the.
yeah. See, I want to continue the execution. Like A is equal to input enter yes, and then I want to print yes. But when the moment you enter, it is asking an input, right? The same thing if you try in Jupyter Notebook, it is working correct. So what I'm trying to say, in
Oh,
the
okay,
next
okay.
line, I want to
Okay,
print
okay.
it.
You mean, okay, okay. Yeah, because yeah, that won't be possible here. Because the way Jupyter works is basically it takes the whole thing and runs at
Yeah,
once. So you can, you could technically do, I think, let's see, you could put a semicolon here, and I think if you could do Shift Enter, no, okay, that's not working. Yeah, the only thing maybe I can think of is basically you can do with semicolons like
yeah.
this.
Yes, at the moment I'm trying like that.
Yeah. And that's okay. Like you don't have to like do everything like what I have over there. You could still type in like in a couple of steps there. But yeah, I see what you mean. So you could probably like kind of stick to this for a bit. But if you do it in a file, then obviously it would work all together. But yeah, because this is so eager to execute, right? Like it doesn't wait for you to
Yeah,
type in code. So yeah, that's why it takes one line at a time. But yeah, in Jupyter, it takes the whole block and runs basically like this. Yeah, I see what you mean now. Yeah, as long as this is working, try this. But yeah, you can just take one at a time. That's also all right.
Can you show me in Jupyter? I'm new to that.
Okay. Yeah, I mean, if you have Jupyter installed, then yeah, you could just like type in full code basically in here. So it's like a Python text file that you could just keep adding, as many lines as you want, and the whole thing gets done at one time, like a file basically.
Okay.
And, yeah, and that's why it's preferred. Like whenever you're writing code, I mean, for regular just Python development, maybe it's not as important. But for data science, because you try a lot of things quickly, right? You try something, come back and change something, and so on. So when you do those sort of like quick modifications, you want the REPL-like interactiveness that you have, but not that you have to like keep running every time. So Jupyter is sort of like a good midpoint, which gives you like a REPL-like ability where you can do things individually, but also if you want, you can write whole files of code as well here. So yeah, Jupyter is good for that. So maybe in one of the future classes, like I thought we'll skip for that a little later, because when we start using like when we get into like a little more advanced topics of visualization and data analytics, that's when we'll start with Jupyter. But maybe we can take like few minutes in the next class, just so if somebody wants to install, everyone can just like set up Jupyter on their system.
Yeah.
Okay, all right.
And
So
here it looks like at least in REPL, / is working as a new line. So for example, if I would like to go to new line without activating enter, then yes, / seems to be working at least in Linux environment. So probably you could check if in Windows if that works too.
/ can you give an example? Let me maybe share this.
Yes. So if you could,
Yeah,
yeah,
I'm here.
just yeah, type /
Mhm.
no, the other slash.
Oh, backslash. Okay.
Yeah, backslash, and yeah, hit enter.
Okay, you mean
Yeah,
for multi-line? Yeah. Okay. Yeah, this would work.
yes.
Yeah, you
Yeah,
can
for
do that
multi-line.
through
Yeah.
this. Yeah,
Yeah.
and you could do. Oh, but it's taking multiple, but looks like it's concatenating still.
No, it's like yeah, instead of adding the line, adding the slash there, try to add slash before equals to. So that is just allowing you to enter the same statement in multi-line.
Okay. You mean, oops. Yeah, I see. You mean like this, right?
Down a slash?
Oh, wait.
No.
Like
What I mean
this?
to say is age slash, yeah, and then yeah, it looks like for you it isn't working. So for me, I can just show you an example.
No, now it's working. So you mean like this then?
Yes.
Yeah, okay. Yeah, I mean, it's still taking only one line at a time, basically. So, yeah, I mean, I
Yeah, one
cannot
statement.
do,
Yeah,
but
one
split
statement,
across.
but multiple lines. Yeah.
Yeah. I mean, yeah, maybe who was the one asking Narendra, right?
Or one expression. Yeah, one expression, but multiple lines.
Yeah. Not quite what Narendra was asking, but yeah, if you have like
Okay.
anything big, then we can certainly split it like this. But yeah, I think it's still. I'll see if because I do remember. So there is one more kind of Python REPL called IPython, which is what Jupyter is based on. So there you have a little more flexibility. Let me see if I have it installed. Now, again, not something I'm asking you to install, but I have it. Yeah, so this is a little more friendly interactive environment than with. So this is kind of like Jupyter in a way. If you say, okay, and it has like nice sort of like comparisons that you saw already and completions rather. Yeah, so it's sort of getting all these already from the Jupyter notebooks we had. So if I do that, press enter, it's giving, okay, it's still doing the same, I guess. Oh, wow, it's actually, yeah, I think it's definitely taking it from the Jupyter notebook. So that's nice. But yeah, I think here it's possible to do, like if I do this and if I press shift enter, oh no, okay, even here it's not happening. Okay, I'll take a look at that, Narendra. I think there was some way to sort of get it, but yeah, if it's there, I'll sort of have it ready for the next class.
Okay.
Yeah. Okay, yeah. I think we are on time today. So yeah, like